In the next two lectures, we're going to take a closer look at each of the planets and several moons individually. In this image, you can see a size scale model of the planets, and notice just how small those inner planets are compared to the outer ones. In this image, you can see the axial tilt and the rotation direction of the planets. Notice that Mercury and Venus are barely tilted at all, while Earth and Mars are tilted almost the same amount. Notice also that Venus is the only planet that spins clockwise. All the other planets spin counterclockwise. Venus's retrograde spin is probably the result of a large collision in its past that actually altered the spin direction. In the last lecture, we described how all solar systems begin as nebulae. A nebula begins to be pulled together by gravity. The sun begins to form in the center, and the small protoplanets and planetesimals form as material farther away from the sun begins to clump up as well. These two words, protoplanet and planetesimal, are used interchangeably. They just refer to the small baby planets that will combine over time to make larger planets. Rocky planets in this early solar system were hot, not just because of all the other objects colliding with them, but also due to radioactive heating. As radioactive atoms break down into smaller atoms, they release heat. Additional heat is generated as gravity crushes the planet down. All this heat causes the planet to begin melting, which leads to the process of differentiation we talked about in the last lecture. Make sure you understand the processes of accretion and differentiation. All of the large rocky bodies in the solar system are differentiated. That is to say, they are layered. Notice, though, that the thicknesses of the layers vary depending on the object. We determine the thickness of these layers using seismology, or studying earthquakes. Notice that the Earth and Venus are relatively very similar in size as well as their layers' thickness. Mercury, though much smaller than the other inner planets, has a huge core compared to its mantle and crust. This makes Mercury incredibly dense, denser than Venus and Mars. In this image, Mars appears to not have a solid core, but new research suggests that it actually likely does have a small solid core based on Marsquake analysis of data collected from a robotic spacecraft called InSight. Earth's layers are better understood because of frequent earthquakes and seismographs worldwide picking up waves generated by these earthquakes. As Earth spins, the liquid part of the outer core also rotates. This generates a magnetic field that surrounds Earth. This magnetic field is really important to life on Earth as the magnetic field protects us from harmful radiation from the sun. Not all planets have this protective field. Mercury has a weak field due to its large core. Venus doesn't spin rapidly enough to generate a magnetic field. Though Venus would probably have been rotating at about the same speed and direction as the Earth, a collision in its past turned Venus's rotation in the other direction. She now spins very slowly clockwise, whereas all the other planets spin more rapidly counterclockwise. Mars's core has cooled too much to generate much of a field either. Compare the Moon and Mercury. Mercury is small, only slightly larger than our own Moon, and they look quite similar to one another. They're both gray, neither has an atmosphere, and they are covered with craters. Earth and Venus have many fewer craters, as most would-be impactors burn up in their atmospheres. Because Mercury and the Moon lack an atmosphere, there are huge differences in temperatures between their lit and dark sides. If you were on the daylight side of Mercury, it would be a scorching 400 degrees Celsius, about 800 Fahrenheit, at only 0.4 AUs from the sun, while on the night side, temperatures fall to a freezing negative 300. This is the widest temperature shift for any planet. Likewise, the moon has a big temperature difference as well, but the moon, like Earth, is 1 AU from the sun, so its temperature swings are less drastic. There are some differences between the moon and Mercury, however. In addition to the craters we see on the moon, we also see darker patches of rock that we don't see on Mercury. A period of time about 3.8 billion years ago, called the Late Heavy Bombardment, saw both Earth and the moon getting impacted by lots of objects. Some of these impactors were very large. They could actually punch through the young moon's crust, forming lava lakes. These lakes eventually cooled, forming darker, smoother areas on the moon called maria. Maria is Latin for seas. And though these aren't seas, people once thought these areas of the moon were water. There are many of these seas on the near side of the moon facing Earth, and almost none on the far side of the moon. The far side of the moon is almost exclusively mountainous and cratered, a land feature we call the highlands. Craters can tell us the age of the surface. Areas that are heavily cratered must be very old. Areas with fewer craters, like the maria, must have formed more recently. In this first image, we see a string of craters that formed when an object was torn apart gravitationally before it impacted, creating a chain of craters. This chain of craters is not on our moon, but on one of Jupiter's moons called Ganymede. This surface is much older than the one in the image on the right that has many fewer craters. The image on the left is a color-enhanced image of Mercury. As you've seen in the earlier pictures, Mercury is not orange and blue, but these colors help to make the different planetary elevations stand out. Blue areas are lower elevation, orange areas are higher elevation. And even though there are higher and lower areas, we don't see the vast, smooth areas of maria that we see on the moon. Additionally, though we usually say that neither the moon nor Mercury have an atmosphere, Mercury does have a very tiny amount of atmosphere that trails behind it in its orbit as the solar wind blows it away. Ice does exist on both Mercury and the moon in permanently shaded craters. These yellow areas indicate where ice exists. The other major rocky bodies in our solar system have some similarities between them as well. In addition to their rocky surface, both Mars and Venus have atmospheres that were generated by past and possibly current volcanic activity. Unlike the Earth, though, the atmospheres of Mars and Venus are made of carbon dioxide. Mars's atmosphere is almost 100 times thinner than Earth's, while Venus's is about 100 times thicker. Due to this thick atmosphere that Venus has, it's actually the hottest planet, even hotter than Mercury. Since Mercury has almost no atmosphere, it doesn't retain its heat. But Venus's atmosphere holds in heat like a blanket. The thick atmosphere also contributes to the fact that Venus has very few impact craters. Many objects getting pulled toward Venus burn up in her atmosphere. Anything that does impact the surface is likely to be covered over by lava flows, so Mars has many more craters than Venus does. If you were on Venus, you would never experience a sunny day. The clouds are so thick that sunlight does not reach the surface directly. Sunlight reflecting off of these clouds is also why Venus looks so bright to us here on Earth. This thick atmosphere comes from volcanic gases. And not only is the atmosphere thick, it's actually poisonous. Most of the atmosphere is carbon dioxide and sulfuric acid. In this image, you can see some of the volcanic domes. The surface of Venus is hot enough to melt lead. Many spacecraft have visited Venus, but none of these spacecraft has survived more than an hour or two on the surface of the planet due to the extreme heat. These spacecraft have shown us that there are thousands of volcanoes scattered all over the surface of Venus. Earth's volcanoes are clustered at tectonic plate boundaries, which we will look at momentarily, but that doesn't seem to be the case with Venus. They're everywhere. We can't be sure whether any of them are active to this day, as Venus's super thick atmosphere prevents us from seeing surface features from Earth. Chances are, though, that Venus may very well have active volcanism. Spacecraft show us that Venus has very few craters, unlike the Moon and other inner planets. This implies that the surface of the planet has been recently smoothed over by lava flows. Some areas seem to have been resurfaced more recently than others. Also, some of the most recent images we have of Venus show hotspots. This is a more thermally active region. The problem is, we can't tell whether lava is actively erupting from this place or if it's just closer to the surface, perhaps just releasing steam from below. The upper right image shows the same location at different times. Notice the new red hotspot in the right image that wasn't there in the left image. This may be showing us an active eruption. Mars's volcanoes are all likely geologically extinct. Mars's volcanoes are confined to one region near a system of deep canyons that are much bigger than the Grand Canyon. This system is called the Valles Marineris. Notice how big the system is compared to the size of the entire United States. These valleys are probably not the result of tectonic movement on Mars. They start near the Tharsis Plateau, where the volcanoes are. And it's likely that the land bulged up under Tharsis while magma was moving to the surface and resulted in a giant set of cracks to the east of the bulge. Mars was very volcanically active in the past, but we don't see any signs of volcanic activity today. This is a picture of Olympus Mons, or Mount Olympus. This is the largest volcano in the solar system. It is much larger than any volcano on Earth. It's 3 times higher than Earth's largest mountain, Mount Everest, and its base is about the size of the entire state of Arizona. Though Mars and Venus both have at least a volcanic past, and maybe Venus in the present, these volcanoes appear to be different in nature to most of Earth's. You're probably familiar with the fact that Earth's crust is broken into multiple pieces called tectonic plates, the largest of which are pictured here. Notice each continent is primarily on one plate, but sometimes it is split. Notice that this bit of Mexico and California that is not on the North American plate. This is why they have so many earthquakes on the West Coast. Those plates shift back and forth there. Also notice that India is not on the same plate as the rest of Asia. These plates are converging. That's why the huge Himalayan mountain range exists. Here is another map of the locations of Earth's volcanoes and earthquakes. Flip back and forth between this image and the last one. Notice how almost all of the volcanoes and earthquakes happen along plate boundaries. Neither Venus nor Mars appear to have tectonic plates. Their volcanoes all seem to be similar to the Hawaiian volcanoes that are not at plate boundaries. Here, lava emerges from a thin spot in the crust. But again, most volcanoes on Earth happen where the plates come together. On early Earth, as these plates were shifting around, gases were released from the molten interior that formed our atmosphere. Most of the early atmosphere was water vapor and carbon dioxide. There would have been hydrogen gas as well, but these atoms are so light and move so quickly that they were actually lost to space. Notice that there is no oxygen on this list. The atmosphere has changed a lot over time due to both geological and biological processes. Photosynthesis, for one, has changed much of the carbon dioxide that was in our early atmosphere to oxygen. Without plant life, the atmospheres of Mars and Venus have probably not changed that much over time. This image shows the process at work. As gases were released from the Earth, especially from volcanic vents, the water vapor collected in the atmosphere. Clouds formed as the water vapor condensed into dust particles in the air. Then the rain was able to fall back to Earth. Acidic rain is what caused our oceans to become salty. Earth and Mars have polar ice caps in common. They both have similar tilt angles and thus have similar seasons and weather, though much of Mars's weather is dust and wind related. Water exists on Mars, not as liquid on the surface, but in other forms we'll look at now. Mars is much colder than Earth as it's farther from the sun. It's also a desert. Many people are confused by this because we ordinarily think of deserts as being hot, but that isn't the case. Desert doesn't mean hot, desert means dry. Antarctica is actually a desert too, as very little new precipitation falls there every year. Though it is a desert, Mars's axial tilt means that it does have seasons. The polar caps change based on the seasons. We even see signs of ancient rivers and oceans on Mars, though the atmosphere is too thin to keep liquid water on the surface today. As a Martian astronaut, if you carried a glass of water outside on Mars, it would boil away, even though it's quite cold. There isn't enough atmospheric pressure to keep the water pressed down into a liquid. You'll also notice that Mars's soil is reddish-brown. The reddish color is due to iron compounds in the soil that have turned a rusty brown over time due to exposure to moisture. Most of Mars's water is confined to the polar ice caps or to underground lakes, but there is some moisture above the surface. Olympus Mons and the other Tharsis region volcanoes have white wispy clouds that form in the colder high-altitude regions. Here is one of the polar caps. Though some of this cap is regular H2O water ice, some of this is frozen CO2, or dry ice. This frozen carbon dioxide is some of Mars's atmosphere literally freezing onto the pole during winter. It later thaws and rejoins the atmosphere in the summer. This freezing and thawing results in thinning and thickening of the atmosphere at different points in the year. And this creates planet-wide wind storms we'll talk about shortly. As I mentioned, we do see evidence of past water flow on Mars. This indicates to us that Mars's atmosphere was once much thicker and has been lost by the planet over time due to the solar wind and weaker gravity. These channels all flow from higher elevation areas in the south to lower elevation areas in the north. Some scientists still believe that these ravines may have been created by lightning rather than water, but most all the evidence points to water existing on Mars in the past. Here's a similar image, this time in true color. Notice the larger channel coming from the bottom right and flowing toward the top left of the image, fanning out into a delta. Toward the right, you see the path water took toward a crater. Mars has an actively changing surface, even though the liquid water is now gone. Here you see areas of sand dunes changing. As the seasons change, huge wind storms develop, shifting the sands around. If you saw the movie or read the book, The Martian, you saw an exaggerated version of these windstorms. The wind would not knock you over, as there isn't enough atmosphere there to cause that much force, but for sand, it's definitely enough. Here you see a true color image of Mars and its atmosphere. In the upper picture, you can see the setting sun. Notice how small the sun looks from 1.5 AUs away. In the lower image, you can see that Mars has an orangey sky rather than a blue one. This is due to lots of dust particles in the atmosphere. Mars has a more blue sky when winds have been low for a long time, but this is infrequent. Mars is known to have planet-wide dust storms, where even surface features are not visible from Earth or orbiting spacecraft due to the dust clouds. Here you see some images illustrating these planet-wide dust storms. Notice in the left and bottom pictures just how much of the surface can be obscured by this dust. In the picture on the top right, you see just how much the sun can be blocked by the dust in the atmosphere. This blockage of light can affect rovers on the surface that require solar power. Here's an image showing Mars's rocky surface. Notice again the rusty color caused by large amounts of iron in the soil. The two hills in the background are called the Twin Peaks. Hopefully you've never seen a tornado in person, but you've probably seen at least a mini dust devil, caused when wind picks up leaves or trash bits in a tornado-like shape for a few seconds. Mars has dust devils that can be pretty large. In the module for Unit 2, I also posted a 1-minute video of this type of storm. They aren't nearly as powerful as the one shown in the Martian movie, but they can be large. Here you see a dark trail that was left behind as a dust devil disturbed the ground over which it moved. In this photo, you can see the dust devil itself in the center as a column of white dust. The dark shadow it is casting to the right, and the trail it is left behind on the left side. This storm was 1 kilometer high, so it's not the same scale as your parking lot leaf twister, but it can be the size of a small tornado, though not as strong. This is the slide in the PowerPoint where the Dust Devil video plays. You can access the video from the PowerPoint or from the links in the module. We have sent several spacecraft to Mars, but we have not yet discovered any living things. The Pathfinder mission had a rover called Sojourner that traveled Mars's surface in 1997. Later rovers called Spirit, Opportunity, and Curiosity have also sampled Martian soil, but no definitive proof of life has been found. The twin rovers, Spirit and Opportunity, landed on Mars in 2004. Each was expected to survive for 3 months, collecting data in the area where it landed. Spirit functioned for 6 years, and Opportunity was in operation until 2018. It should have lived for 3 months, but it survived 14 years. It had traveled over 26 miles, which is more than 50 times farther than the original goal. That may not sound like a lot, but try controlling a remote-controlled robot from a couple 100 million miles away when you can't see where you're going. You'd drive slowly too. The Curiosity rover is bigger than the other rovers. and it's about the size of a Volkswagen. Curiosity took a selfie using its robotic arm that is not seen in this picture. This is actually a composite image formed from cropping and sticking multiple images together so his arm holding the camera is not visible. There's a really cool free app called Spacecraft AR. You can use it to look at and manipulate different spacecraft. You can rotate them, look at them from different angles, and even move the robotic arms. We'll play with it a little bit in the face-to-face classes. These rovers were not intended to look for life directly. They were analyzing soil and atmosphere samples to determine whether the conditions on Mars were suitable at one time for living things. Conditions at the surface of Mars are not conducive to life now, though they likely were in the past. Conditions below the surface quite possibly are still favorable to life, and there may be tiny Martian microbes living in the soil. The Perseverance rover has been on Mars the shortest amount of time. It is looking not just for conditions on Mars, but evidence of past or even continuing life on Mars. It's collecting samples into tubes that are being left behind on the surface of Mars that will be collected by a future mission and returned to Earth. Often called Percy, Perseverance carried a helicopter called Ingenuity, or Ginny. It was designed to be a proof of concept experiment, something just to prove that flight was possible on Mars. It was expected to last only a couple of weeks and take a handful of short flights. Ingenuity ended up functioning for over 2 years and took over 50 flights. Each of the inner planets, other than the Earth, are named for Roman gods. Mercury was the messenger of the gods, and he was fast. Hermes is the Greek version of this same god. Since Mercury circles the sun in only 88 days, being the fastest planet, it was named for this speedy god. Notice the wings on his shoes. You may recognize that the Goodyear Tire Company's logo also looks like a winged shoe, also based on this god. Venus is the only planet named for a woman. Venus is the goddess of love in Roman mythology. Aphrodite is the same goddess, but in the Greek culture. Ancient people named the planet Venus after the goddess Venus because it was the brightest planet and was considered the most beautiful. Almost all the landforms and craters on Venus are named for famous women. Mars is the god of war. Ares was his Greek equivalent. The planet was named Mars because from Earth, Mars appears red. Early people thought that there must be very warlike Martians who were always fighting and bleeding all over their planet. Each of these symbols is a shorthand representation of each of the planet's names. You don't need to memorize these symbols, but you may see them on sky maps. Now, let's talk about moons more generally. Though Mercury and Venus don't have moons, Earth has only one, and Mars, sort of, has two. There are hundreds of moons in our solar system. Most of them seem to have formed as a result of impacts between objects or other objects that were gravitationally torn apart. In the case of our moon, evidence suggests that the moon was actually born from Earth. Models show that a Mars-sized object called Theia, impacting the Earth, would have left most of the core material behind with the Earth, but a large amount of lower density crust and mantle material would have been ejected into space. This material would have formed a ring around Earth that would eventually coalesce together, forming the moon. Here you see a computer model and an artist's conception of how this might have occurred. You see the impact and the ring material. Similarly, Mars's moons likely came from Mars itself. Though old ideas hypothesize that Mars's moons might be captured asteroids, that's unlikely to be the case. Mars's moons don't chemically match any known asteroid type, but they do have the same chemical composition of Mars. Mars has what is called a hemispheric dichotomy, which is basically a fancy way of saying that the northern hemisphere looks nothing like the southern hemisphere of the planet. Look how cratered and mountainous the southern hemisphere looks. This orangey-red portion of the planet on this topographic map. Now, look at the nice uncratered blue portion. This is showing you a much lower elevation area. It looks like halves of two different planets. Some large object impacted Mars and erased all the features and created that deep basin on the northern half of the planet. That impactor ejected so much material out into space that these two very small moons accreted from it. The lower elevation area is where Mars's water would have been billions of years ago. That's also why there are very few craters in that area. It's a younger landform. The outer solar system planets have many more moons than the 3 we see in the inner solar system. Most of them are boring balls of ice and rock, but there are some unique ones. Jupiter's Io is the most volcanically active body in the solar system. You can see it casting a shadow on Jupiter in the first image, and you can see just how big Jupiter is compared to this tiny moon. In the second image, you see pockmarks of the individual volcanoes. In the infrared image on the right, you see how many volcanoes are active all at the same time. Since Io is much smaller than Earth, it should have cooled much more rapidly than Earth and be completely solid. However, its close proximity to giant Jupiter means that the large planet is continually pulling on Io gravitationally, squishing it like a ball of Play-Doh. This keeps Io melted in the interior so that it can continue erupting long past the time when it should have cooled. Europa may be the most exciting moon of Jupiter. Though it looks mostly like a snow and ice ball, it is so much more. Here you can see lots of cracks that have formed in Europa's frozen surface. These cracks and ridges are faults. They prove that below Europa's frozen crust, there is an ocean of water moving that comes up to freeze when cracks form. Could there be alien life in the ocean inside that moon? We don't know. It's not likely that there are European fish swimming around inside that moon, though it is possible that there's bacterial life somewhere within that water. Here you see an image of what appear to be volcanoes erupting on the surface of this tiny moon that orbits Saturn. Instead of erupting lava, however, these are cryovolcanoes, spewing out water and other compounds that turn immediately to ice crystals. These ice crystals feed highly reflective material into Saturn's ring system. Some of these particles contain salt as well, meaning that the subsurface ocean may be similar to Earth's oceans. We don't know whether there might be organisms living in this ocean below Enceladus's icy surface. These geysers only occur in Enceladus's southern hemisphere, in the area called the Tiger Stripes. Thermal images taken by Cassini indicate that this area of the moon is considerably warmer than the rest of the moon's surface. In these areas, either the ocean is closer to the moon's surface, or perhaps the ocean exists only under this part of the moon. This ocean appears to have all the compounds known to be needed for life and an energy source, so perhaps there are microbes living inside this tiny moon. Titan is Saturn's largest moon. It's the second largest moon in our solar system, and it has a thick nitrogen atmosphere, much like Earth. The atmosphere also contains a lot of methane, natural gas, or CH4. Earth has a water cycle, but Titan is too cold to support liquid water. Instead, it has a methane cycle, with what appear to be methane lakes on the surface and methane as vapor in the atmosphere. Titan is the only moon other than our own moon that has been landed upon. The Cassini orbiter had a probe called Huygens that was dropped onto Titan. As it was coming down, the picture on the right was taken. These dark spots are most likely lakes of liquid methane. Though methane is a gas on Earth, Titan is so cold that the methane would naturally be a liquid. The picture on the right is of Titan's surface, taken after the Huygens landed. The small pebbles seen in the foreground are only a few inches across. Neptune's largest moon is called Triton. It is the only large body in the solar system that orbits in a retrograde direction. Recall that Venus rotates in the opposite direction, but she does revolve around the sun in the proper direction. The fact that Triton orbits backwards means that it probably did not form with the rest of Neptune's moons, but was probably captured later by the planet. It probably originated in the Kuiper Belt, where Pluto lives, and wandered too close to Neptune, getting caught in Neptune's gravitational field. And finally, this slide is just an image that allows you to compare the sizes of smaller terrestrial planets, Mars and Mercury, with some of the moons and dwarf planets in our solar system. Notice that moons Ganymede and Titan are actually larger than Mercury. Also notice that dwarf planet Pluto is also quite a bit smaller than several moons. We'll discuss some of these dwarf planets in the next 2 lectures.